Let's talk about the chemistry of alkenes, alkene formation and alkene reactions. We can do one way of forming an alkene is by dehydrating an alcohol, a primary alcohol ideally. Basically the hydroxide of the carbinol carbon and the hydrogen of an alpha carbon, they hook up and they form water, and it results in the formation of a double bond. We can do this with dehydrating reagents like concentrated sulfuric acid 170 degrees Celsius, P2O5 delta, Al2O3 35 degrees Celsius, H3PO4 delta, dilute H2SO4 delta. The list goes on. Well, actually it doesn't. These are the ones we have. Another way of doing so is by adding alcoholic KOH into an alkyl halide. What happens is this X goes away, it runs away with an H of this compound, and it will form a double bond. Yeah, this is called dehydrohalogenation, by the way, for those who are interested. Okay, this mess is called Lindlar's reagent. Lindlar's reagent is basically used for partial hydrogenation of alkynes into alkenes. Basically the reagent is H2 palladium barium sulfate delta and quinoline, and you can turn alkynes into alkenes by this means. Now for alkene reactions, you can, as we saw earlier, you can catalytically hydrogenate alkenes into alkanes using H2 delta and using a catalyst like nickel, platinum or palladium. If you have a alkene, you can add Br2CCl4 and add bromine to the two sides of the double bond to form this. That's pretty straightforward, right? Or you can this is a more complicated reaction. Actually it's not complicated at all, it's just a mechanism that is that's not complicated even actually. Basically there is one side that forms a more stable carbocation in the mechanism, and that side is the side with the more alkyl groups. So basically if you were to add HBr, the hydrogen will add to one carbon, bromine will add to another carbon, the bromine will add to the carbon that will form the more stable carbocation, in which case it is this carbon. This is done under something called, this is overlooked by something called Markovnikov's theory, Markovnikov's rule actually, and the bromine gets added to this carbon to form this, while the hydrogen gets added to the other. If we were to do so with H2O2, it goes through a free radical mechanism and will produce something called an anti-Markovnikov product, which is this, where the bromine adds to this carbon and the hydrogen adds to the other carbon, the carbon that produces the most stable carbocation. If we were to add concentrated sulfuric acid into an alkene, this group OSO3H will add to the most stable carbon, while hydrogen will add to the less stable carbon, just like with over here, via Markovnikov's rule. But if we were to add H2O, we will discuss the mechanism later, this OSO3H group becomes an OH group. So far so good. If we have an alkene and add alkaline permanganate solution known as Bayer's reagent to the carbons in both sides, we get an OH added. So basically it becomes a diol. In this case we call this specific case a vicinal diol because they have two hydroxide groups in a vicinity, and manganese dioxide will be formed as well. What happens if we oxidize alkene? If in one side we have a CH and a double bond, it will be oxidized into carbon dioxide and water. If it is a carbon with two alkyl groups, it will form a ketone, it will be oxidized to a ketone. While if it is R, C, and if it's an R and a H group that is added, it will form a carboxylic acid. It oxidizes into a carboxylic acid. It goes through the aldehyde phase, but the aldehyde also oxidizes to form the carboxylic acid. And that is the chemistry of alkenes.